Hey, my dears, today we are going to talk about reflection. So we're going to start with some notes on our reflection. So the first thing you need to do is you need to watch the introduction video that is linked in Canvas before you get started on these notes. Once you watch that video, then you can get going on these notes. So a transformation is a function that maps a given figure called a pre-image onto a resulting figure called the image. So the pre-image is where we begin. It's our starting picture. And the image is our resulting picture after we do some kind of transformation. A rigid motion in a transformation preserves size and shape of the figure. In other words, the picture does not get any larger or smaller. It stays congruent. And so rigid just means it's not getting bigger or smaller. A reflection or a flip is a rigid motion in which a figure and its image have opposite orientations. Thus, a reflected image in a mirror appears backwards. So as you watch that video, you kind of notice when you're looking at a reflection, right? Like if you raise your right hand in the mirror, it looks like you're raising your left hand. Essentially, the orientation or the direction that you're facing on a graph changes. Now, in the diagram below, a reflection in line R is a transformation for which the following is true. If a point is on the line of reflection or on the line that you can think about as your mirror line, if a point is on that line, it is going to map onto itself. In other words, it's not going to move if you're actually physically on this line of reflection. It doesn't go anywhere. If you have a point that is not on the reflection though, not on that line, then it creates a perpendicular bisector. Perpendicular meaning, of course, it has an opposite reciprocal slope. Bisector means that it's cutting the segment in half. So this line would go right through the very middle, the midpoint of this segment. So that's something important to kind of keep in our brains as we're moving through. Okay, so our first reflection, I've already graphed it, but our first reflection is going to reflect across the x-axis. So I'm going to start by just highlighting my reflection line. So here's my x-axis. Okay, and so this picture right here is called my pre-image, and I just labeled it as point A, B, and C. So this is where I am beginning before I do any type of reflection. From here, I'm going to reflect it across this x-axis. So essentially, you can think about it as like if I were to fold my paper right here on this pink line, everything that's above the pink line would come below and vice versa if I were to flip it. Okay, so the distance between each of these points should be the same distance as you're going towards this line of reflection. So point A is 2 above my line of reflection. So when I flip it, it should go 2 below my line of reflection. And to show that this is a reflection point, I'm going to put a little tick mark next to the A. This is called A prime, and this shows that a picture is being transformed in some way. So it's talking about the resulting figure. It's got the little tick mark. So B, I would do the same thing. I go down 3 here, so then I would go, or sorry, I go up above 3, so I would go down 3 below. 1, 2, 3. So here's B prime. This is not a good pen. And then my it stays exactly where it is for C prime. So what we've just done is we've done a reflection. We've flipped our graph. Flipped our picture. So A prime, the coordinates of A prime are 3, -2. That's this one right here. B prime is -1, -3. And C prime is staying exactly the same. It's 1, 0. So this was my pre-image, and this piece over here, this is called my image. Okay, so as we're moving from the pre-image to the image, all we're doing is we're looking at the X and the Y values, and we're seeing how did those X and Y values change. So if you look here, my X's, 3, -1, 1, they stayed exactly the same, 3, -1, 1. They did not change. So my X's stay the same. And my Y values, if you look, I went from 2, 3, 0 to -2, -3, 0. So my Y values essentially changed signs. They went from positive to negative. So my Y's changed sign. So when I write this as a mapping notation or as a rule, we write it as XY implies or XY yields or XY becomes, whatever, however you want to say it, XY becomes my x stays the same, so I leave it as x, and my y changes sign, so I put a negative sign in front of it. That negative does not mean make it negative, it means change the sign. If it was positive, make it negative. If it's negative, make it positive. So there's our first reflection over the x-axis. My second reflection is over the y-axis. So it's the same idea, except this time instead of flipping it from top to bottom over the x-axis, I'm now going to flip it over the y, which is this line right here. So again, it should be the same distance when I reflect from the pre-image to this new image over here. Okay, so all I'm going to do straight up is just count like I did before. So if I look at A is 3 to the right of this pink line, so I'm going to go 3 to the left. And it's A prime. B is to the left of the line by 1, so I have to do the opposite, which is to go to the right of the line by 1. And then C is to the right by 1, so I go to the left by 1. So it is going to overlap just a little bit, and that's okay. Okay, so if I'm going through to put these into the coordinates themselves, my A is -3, +2. My B is +1, +3. And my C value is, C prime is -1, 0. So if you go from the pre-image to the image, this time our pattern that we see is if we look at our X's, this time our X's changed signs and our Y's stayed exactly the same. So it was essentially just the opposite of what I did before. So my X's changed signs and my Y's stay the same. So if I write it in mapping notation, I go X, Y yields, my X change sign, so I write -X, and my Y's stay the same, so I write a Y. Okay, and we're all done. There's our reflection over the Y-axis. Okay, we've got 2 more reflections. Now, reflection number 3 is a little interesting because this is a reflection across the line Y equals X. The line Y equals X means like any number you plug in for your Y value will also come out to be your X value. So if you plug in a 0 for Y, that means your X is a 0 as well. So that's the origin. If you put a 1 in for your Y, that means you get a 1 for your X. So that's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and same by negative. So it's essentially a diagonal line that just cuts this graph right in half. And since it's Y equals +X, it is a positive line, a positive slope. So there's my line I'm going to reflect over. Now, this one's tricky because since it's kind of diagonal, it's a little harder to kind of visualize what the reflection point is. But think about it as like the A and the C are to the kind of like to the right, I guess I would say, of this pink line. So when they flip, they need to go to the left. They're going to be right over here-ish. And then the B is on the left, so it needs to flip over to the right side. So it's definitely going to overlap. So what I can kind of do is like the A is, I don't know, we'll call that maybe like halfway to that pink line. So if I also go halfway over here, this is my A prime point right there. And A prime, the coordinates of that point is 2, 3. So before I try to like eyeball the rest, what I can do is just try to look and see if I see a pattern. So I was at 3, 2, and my new image is 2, 3. Essentially what I'm doing is I'm just taking the X and Y and they are trading places with one another. So if I did the same for my B, instead of -1, 0, it would be +3, or sorry, -1, 3, it would be +3, -1. So if I were to fold my paper on this pink line, essentially what should happen is, I'll try my best to show you, this point B and this point B prime, they should touch, which you can kind of see. It's so hard to see, I'm sorry. You can kind of see that they're touching there when I fold them in half. That's how I know I'm doing it correctly. So this is B prime. And then C prime, instead of 1, 0, will be at 0, 1, which is right here. And now you have reflected over this line here. And again, they just trade places, 3, -1, and 0, 1. So our rule is that our x and y's trade places. So when I write it as a coordinate mapping notation, I write it as xy becomes yx. They just trade places. Okay, last one. Reflection number 4 is reflecting the lines, points across the line y equals -x. So negative means it's essentially the same as this picture here, but instead of a positive graph, I'm making it a negative graph. And so it's a negative graph that goes through the origin that moves 1 by 1. And so this one's way easier, I think, to try to flip it over to the other side. Again, you can kind of fold your paper and match up where those points go. But I'm going to start with this C value one. Again, here's halfway. So right here would be, if I folded this paper, that would be my C prime. So my C value is at 0, -1. That's kind of a tricky one to see what the rule is because I've got zeros with it. So I'm going to try another picture or another point. I'll go for the B. So if I went over, up 1, I have to do the opposite, left, down 1. So they should be the same distance apart. Okay, so B prime is at -3, +1. So if I look from my pre-image to my image, to my B prime here, B to B prime, what I'm seeing is I went from -1, 3 to -3, 1. So not only are they trading places, they are also changing signs. They're doing both, trading places and switching signs. So our rule is that x and y trade places and x and y change signs. So 3, 2 should become -2, -3. And there's my graph, and it's now been reflected over that line, y equals -x. So my rule as a mapping notation is xy becomes -y, -x. So last part of my news, we're just going to summarize our results. I'm just going to put my final answers here so they're all in one spot. If you reflect across the x-axis, the x stays the same, y changes signs. If you reflect across the y-axis, the y stays the same, the x changes signs. If you reflect across the line y equals x, they trade places. And if you reflect across the line y equals -x, they trade places and they change signs. So I would put a nice big something around that because that will not, oh my gosh, excuse me, that will not be given to you on your midterm. And this is like a huge section on your midterm. So you do have to have this memorized, unfortunately for you. Boogie. Last one for reflections, number 5. After a reflection, point A is at 4, 6, and it goes to point A prime, which is -8, 12. What is the equation of the line of reflection? Now, we've already had some practice writing equations of lines. We know to write an equation of a line, I need to use y equals mx plus b. We also know that if a point is not on the line of reflection, it is going to create a perpendicular bisector. So perpendicular, again, means that the it's going to create 90-degree angles, and then bisector means the point directly in the center. It has to divide the segment in half. So I essentially need the midpoint in order to do this. So the first thing I'm going to do is just figure out what's the midpoint of these 2 points that we started with and we reflected with. So the first thing I'm going to do is find the midpoint. To find the midpoint, we take the averages of the x's and the average of the y's. So if I look at my x values, I have 4 and -8. So I'm going to add them together and then divide by 2, right? The average. So -8 plus 4 is -4, divided by 2 is -2. And then for my y's, same thing, 6 plus 12 is 18 divided by 2 gives me 9. So I know when I write the equation of my line, I want it to go through the midpoint, which is point -2, +9. Okay, so that gives me the x and the y. That gives me the point, right? This part, x and y. I need to know what the slope is, and I need to solve for the b. Now, to find the slope, remember slope is rise over run or change of y's over change of x. Or apparently if you are Miss Steve's, it's like martinis on a table, which is what she told you. So I think that was it. How your y's change and how your x's change. So if we're looking at just our y values to get from my original pre-image to my image, going from 6 to 12, what am I doing? I'm adding 6. For my x values, to get from 4 to -8, I am subtracting 12. So my slope is 6 over -12, which I can reduce to be -1/2. Now, that's great, but I'm writing the equation of a line that is perpendicular to this one. So that means I have to use a perpendicular slope. And remember, if lines are perpendicular, their slopes are opposite signs and reciprocals. So they trade places and they change signs. So instead of -1/2, it becomes a +2/1 or just a +2. So now I have my midpoint. I have the slope I want to use. I now can plug into the equation y equals mx plus b and solve for my b value. So for y, I'm going to plug in over here my midpoint. So the y value is going to be 9. The slope I'm going to plug in is 2. The x value I'm plugging in is this one from my midpoint times -2. And then I have to solve for b. So this is just a quick algebra problem. I multiply 2 and -2 to get -4. And then I add 4 to both sides. I get 13 equals b. So my final equation of my line that I reflected from A to A prime is y equals 2x plus 13. Hooray, and we're done. I promise you, your next quiz that I give you, you're gonna have a question like this on your quiz. For sure, so make sure you know how to do it. Oogie. The only other one I wanna do is on the back, and then you're gonna move on to your translation notes. Okay, so number 5 on the back says reflect the figure across the line x equals -2. Now, x equals -2 means it's a line that crosses the x-axis, and this is the x-axis. So it touches the x-axis at -2. So that's this line right here. And it's a vertical line at x equals -2, excuse me. From there, all I have to do is count. And so I just say, okay, like point B is 1, 2, 3 away from the line. So I go 3 to the other side. 1, 2, 3. There's my B prime. My A point is 1, 2, 3, 4, 5 away from this line. So I go 1, 2, 3, 4, 5 to the other side. There's point A prime. And so on and so forth. So when it comes to problems that have equations like this, you have to draw the line in and then you just count from there. You should be good to go. Okay, so at this point, I would like you to make sure that you have all of your notes completed for this section. And when you're done with this video, excuse me, you could go on to the translation notes. So I hope this was helpful. Okay, bye. See you in a minute.